Good afternoon. All right. So this is our last week of class, right? Because next week will be the exam. So we are going to focus on the exam review this week. We'll get through, and I'll slow down and take my time with this because we've got, 4 days to get through it. And then if there are certain questions where you really feel like, oh, I really would like more of that type of question, let me know, right? And then that way I can kind of find some other ones and we'll work through those also. Okay, so that's kind of the goal, is to work through the exam review, and then with whatever time we have remaining. I'm also going to show you a couple of things in the calculator that I haven't shown you along the way, because I think it's nice to know those things. And I'll also show you some websites, that you won't have available for the final exam, but especially like for homework or if you're just working through problems, there's some websites out there that are really nice in terms of, doing the problems quickly so you can check yourself. And also showing you steps in a lot of cases in case you need to see those steps. Okay, so I'm going to show you those things also this week. In terms of things to do, don't forget everything else is already submitted, right? So it's only the final exam at this point, which means that I've actually already gone in, put all of your grades in, and dropped your lowest test and your lowest homework grade. So please take a look at your grades. Let me know if you have any questions about that. Your lowest grade will still show up in the grade book, but it will not be counted. Okay, so just know that, even if, let's say your lowest grade is a 75, it's not going to just take that out, right? It's still going to show all 5 tests, including the 75, but then that 75 would be the one that gets dropped, and so it's not actually being calculated into your final grade. But if you have questions about anything that I have in there, especially now that I've finished grading that last test, please do let me know. So that I can make sure I get any changes made to grades that need to be made. Okay, so check your homework grades and check your test grades. If anything's missing, especially, let me know so that I can go back and figure out why it's not in there. Okay. If you have a question about what you would need on the final to get a particular grade, let me know that too. The final exam is 20%, so you should be able to kind of say, well, I know that all of this, whatever your grade is right now, is 80%. And then you can figure out what the other 20% would need to be to get whatever grade you're aiming for. But if you have questions about that, let me know, and I'll be happy to tell you what you would need on the final exam. Okay. Last thing is, if you have not already signed up for an exam time, please do that by the end of this week. I know a lot of people were waiting on work schedules and that kind of thing, but try to go ahead by the end of the week and schedule a time for your final exam. Again, it's just clicking on that survey link, putting in your email address, your name, choosing a day, choosing a time, right? And it's 2-hour windows starting at 8 a.m. and ending at 10 p.m. at night. Okay. I think that's all in terms of my announcements. So any questions, comments, concerns before we get started on the review now? All right. As always, if you think of anything throughout the week, please email me and let me know. And then also, if you have particular questions from the exam review where you're like, oh, I really wish I had more of those, let me know that too. That way I can start looking for those, and we can work through those later in the week once we get through all these first ones. Okay. Final exam will be very similar to this exam review. So you can expect, about 10 questions, similar in nature to the ones that are on the practice exam. It covers a variety of topics, usually about 2 questions per unit since we've had 5 units. So I tried to kind of spread it out, so that it kind of covers everything. All right. So let's take a look here then at example 1. All right. So this one was in 3 parts. So this is part 1 of that. We're looking for the limit as x approaches -3 of x squared plus 3x over x squared minus x minus 12. Okay, and I need to see this done algebraically, right? So whenever I'm asking you to do these, just assume that it's algebraic. So what would we need to do first here if I want to find that limit? Good. So we need to factor first, right? I cannot direct substitute because that would be undefined in this case. We need to factor first. So I'm going to take the limit as x approaches -3. What would be the factors of the numerator here? Good. So x times x plus 3. And then if we factor the denominator, what's that going to give us? Good. X minus 4 and x plus 3. All right. So now that we've factored, then we can do what? Okay, good. And if we simplify this, what are we going to get? Yeah, the x plus 3 cancels out. So now we're left with the limit as x approaches -3 of x over x minus 4. So that's the whole purpose of factoring here, is to see if we have any common factors that we can cancel out. Once we do that, now what can we do? Now we can direct substitute. Good. So now I can just plug the -3 in because it's no longer going to be undefined in the denominator. So we'll have -3 over -3 minus 4. And so if we simplify that now, what are we going to get? Okay, so we do -3 over -3 minus 4. Make sure that your -3 minus 4 is grouped together, and do that first, right? Yeah, so this becomes -3 over -7, and then a negative over a negative is a positive. So this is 3 over 7. If you try to put this in the calculator and don't group the denominator, it's going to divide first and give you 1, and then 1 minus 4 will be -3, but that's not right. Okay, so just make sure you simplify the denominator first. Okay, so our limit this time is just 3 over 7. Any questions on that one? All right, part B. Okay, same thing, we're looking for the limit. As h approaches 0. Infinity or negative infinity divided by. That's right. Yeah. So if you have something where you're looking at infinity or negative infinity, always look for that highest exponent, the degree in the denominator, and divide all of your terms by that. Hopefully at that point it gives you something where you can actually start to substitute the infinities and think about where those limits are approaching 0 or where we have constants, right? So that's the goal of that. Okay. All right, so if we look at this one now, if we're looking at the limit as h approaches 0, again, we can't direct substitute because that would give us 0 in the denominator. So what are we going to have to do first this time? Good. Expand out the -5 plus h first, right? So we're going to get limit h approaches 0. If we do that, it's -5 plus h times -5 plus h. So what's that going to give us? Good. So 25 minus 10h plus h squared. And then we bring over the minus 25. All that's over h. Any questions about that step? All right, so now if we combine like terms in the numerator, what are we left with? Good. So the negative 10h, make sure you keep the negative, and then the positive h squared because the 25s are going to cancel. Negative 10h plus h squared over h. And then we can do what? Good. Factor out the h from the numerator. So we have limit. H approaches 0. It's going to give us h times negative 10 plus h over h. And now we can do what? Okay, good. The h's are going to cancel, right? Because we have this common factor of h. And so really we're just left with the limit as h approaches 0 of negative 10 plus h. And that would give us what? Just negative 10, right? Because we can direct substitute at that point. Negative 10 plus 0 is just equal to negative 10. Any questions on that one now? All right. So our last limit one, we got limit as u approaches 2. And we got square root of 4u plus 1 minus 3 in the numerator, u minus 2 in the denominator. Again, we can't direct substitute because that would give us 0 in the denominator. So what are we going to have to do first this time? So we actually don't need to change the square root to a 1/2 power this time. Remember, that's useful for derivatives, right? But in terms of our limits here, it's not really going to do us much good. Good, right? We multiply by the conjugate of what we have in the numerator this time so that we can try to get rid of that square root up top and maybe get something that's going to cancel out so that we can direct substitute. So that means we're multiplying by square root of 4u plus 1 plus 3. Whatever we do to the numerator, I have to do the same thing to the denominator. Okay. All right, so if we do that now, limit u approaches 2, what's that going to give us in the numerator? Let's keep in mind it's FOIL, right? Good, right? So the square root of 4u plus 1 times the square root of 4u plus 1 would just give us 4u plus 1. So we get 4u plus 1. Outer and inner terms are going to cancel, and that's the whole purpose of multiplying by the conjugate. So then our last terms will be negative 3 times positive 3 is going to give us a negative 9. Any questions about how I got that for the numerator now? All right, now in the denominator, I'm going to keep this factored, right? There's no real reason to actually multiply this out. I'm just going to keep my u minus 2, and we're going to keep the square root of 4u plus 1 plus 3. All right, now, if we combine like terms, we have 1 minus 9. That's going to give us a negative 8 in the numerator. We got limit u approaches 2, 4u minus 8 over u minus 2, square root of 4u plus 1 plus 3. Okay, so what can we do at that point? Okay, good. And so what's our factor in the numerator? Yeah, we can factor out the 4. So we get limit u approaches 2, 4 times, that's going to leave us with u minus 2 over u minus 2 times square root 4u plus 1 plus 3. All right. So then what happens? Good. Now we have that common factor of u minus 2. We can cancel that out. So now we're just looking for the limit as u approaches 2 of 4 over the square root 4u plus 1 plus 3. At that point, we can direct substitute because that's no longer going to give us 0 in the denominator. So we have 4 over square root of 4 times 2 plus 1 plus 3 on the outside. So if we simplify that now, what are we going to get? Good, 2/3, right? Because this gives us 4 over 3 plus 3, 4 over 6, and that simplifies to 2/3. So anytime you see a square root like that and you can't automatically direct substitute, multiply by the conjugate, see if you have any common factors that cancel out, and then hopefully at that point you'll be able to direct substitute to get your limit. Any questions on that one now? All right. So now we want to find f prime of x using the limit definition of a derivative, right? So I don't want you to use the shortcut here. I want to make sure that you know that limit definition for a derivative. So we're going to take the limit as h approaches what value? Zero, right? So remember your limit definition for a derivative, limit as h approaches 0. What's going to go in the numerator? Ignoring the function itself right now. Let's just think about the general formula for the limit definition. What goes up top? Good, right? So we take f of x plus h minus f of x. And then in the denominator, we're just going to have what? Just h. Good. So that's our formula now for the limit definition for a derivative. Right? So make sure you know that. Now we need to substitute and simplify so we can find this limit. We're going to do limit h approaches 0. So the f of x plus h, remember we're just substituting x plus h everywhere we see an x. So that's going to give us 3 times x plus h squared minus 4 times x plus h plus 1. Then we're going to subtract f of x. Just make sure that you're putting all this in parentheses now because we're subtracting the entire function. 3x squared minus 4x plus 1 all over h. Any questions on that step? All right, so now we just need to simplify that numerator. First thing is, let's do the x plus h squared. What's that going to give us if we expand that? Good. So x squared plus 2xh plus h squared. Because again, that's just x plus h times x plus h. Use your FOIL, combine like terms, and that's what you should get. That should be on the inside. And then we can distribute this negative 4 here. So that's going to give us a negative 4x minus 4h plus the 1. And then down here now we can distribute the negative, which gives us a negative 3x squared, positive 4x, and a negative 1. And make sure you distribute the 3 here, so then we can start looking for like terms. We'll have 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus the 1 minus 3x squared plus 4x minus 1 all over h. All right, so then look for your like terms. So once we combine like terms here, what are we going to get in the numerator? Okay, so if I start combining like right, so the 3x squares cancel, the negative 4x and the positive 4x cancel, and the 1 and the negative 1 cancel. So then we're just left with the 6xh plus 3h squared and the minus 4h all over h. All right, then what do we do at that point? Good. Now we can factor out the h in the numerator. We got limit as h approaches 0, h times 6x plus 3h minus 4 all over h. And then we can divide out the h. And so if we take our limit now as h approaches 0, we can direct substitute what we have left over there. We have 6x plus 3 times 0 minus 4. Just be careful there. Make sure you're only putting 0 in for the h value, not the x value. And so when we simplify this now, what's that going to give us? Good. 6x minus 4. Now, the nice part about these is it's really easy to check yourself, right? So if we look back and just use our power rule up here at the very beginning, f prime of x, 2 times 3 is 6, drop the exponent by 1, derivative of negative 4x is just a minus 4, so we did that correctly. Any questions on this one now? Again, that limit definition will not be given to you, so make sure that you memorize the limit definition of a derivative. All right, so now we're going to use implicit differentiation. We're looking for dy dx, okay, or y prime if you want to think of it that way instead. So remember, with implicit, we don't have to move anything around. We can just go term by term, take our derivative. We just have to make sure we're applying our rules properly. So if we look at that first term now, y to the 5th power, if we take the derivative of that, what are we going to get? Good, right? So power rule here gives us 5y to the 4th. But because we're taking the derivative with respect to x, we need a dy dx. I'm going to use y prime just so I don't have to write dy dx every time. We know that's what we're actually going to be solving for at the end. All right, then we look at the second term here. So what are we going to have to do to find the derivative of x squared y cubed? It's a product, good, right? So we have to use product rule. Think of x squared as your f, think of y cubed as your g. If you need to write out the steps over to the side, that's fine. Or if you can do it in your head, that's fine too. What's our derivative for f going to give us this time? Just the derivative of x squared. Good, 2x. And if we take the derivative of y cubed, what are we going to get? Good, 3y squared. And then we just have to remember the y prime or the dy dx. So now if we use our product rule with all of that, what's that going to look like? Good. So x squared times the 3y squared y prime, that's the f times the g prime. Plus, and then we have to multiply the g and the f prime, so that's going to give us the y cubed times the 2x. All right, so that takes care of the left-hand side. Now we have to go to the right-hand side. So that first term there, what's the derivative of 1? 0, right? So that's going to go away. So we're really just worried about the x to the 4th y. So again, that's going to be another product now. So if you want to do the steps over here, say x to the 4th, g is just y, f prime then is 4x cubed, and g prime is just y prime. Okay, so then use your product rule again. It's going to give us x to the 4th times y prime plus y times 4x cubed. Any questions about that first step of finding just the derivative before we actually solve anything? Now, before I start moving anything around, I'm going to go ahead and clean this up a little bit just so the multiplication looks a little nicer. So we've got 5y to the 4th y prime plus, just going to move my coefficient out front here, 3x squared y prime. Same thing here, just move the 2x to the front, so 2xy cubed. Other side now, we've got x to the 4th y prime. And then here, I'm just going to move the coefficient. I'll move the x first, so 4x cubed y. All right, now, at that point, what do we need to do? Get all the y prime terms together, right? So I notice here I've already got 2 of them on the left. So I'm just going to go ahead and move this other one left and then just move this 2xy cubed to the other side. So I get all the y primes together and everything else on the other side. So I'm subtracting x to the 4th y prime from both sides. And I'm going to subtract this 2xy cubed from both sides. So now we're left with 5y to the 4th y prime plus 3x squared y prime minus x to the 4th y prime. On the other side, we have 4x cubed y minus 2xy cubed. All right, so then once we get all the y primes together, then we can do what? Factor it out. Good. So that's the whole point of getting the y prime together, is so we can factor out the y prime, and then we can divide to get rid of it, or get rid of everything else and get it by itself. So we get y prime times 5y to the 4th plus 3x squared y squared minus x to the 4th. Right-hand side stays the same. Like I said, at that point, once we have the y prime factored out, we can just divide by everything in that set of parentheses there to get y prime by itself. So we're just going to end up with 4x cubed y minus 2xy cubed all over 5y to the fourth plus 3x squared y squared minus x to the fourth. And just remember here, right, if you had moved things the other way instead, right, and gotten all of your y primes on the right and everything else on the left, the only difference would be that all of your signs would be different in your final answer, but that's still equivalent, right? You'd still get full credit for that. Any questions on that one now? All right. So now we want to use implicit to find dy dx for this one. Okay, or again, y prime. If you want to use y prime instead, that's perfectly fine with me. All right, so the only difference this time, we've got some trig functions in there. So what are we going to have to do to find the derivative for that first term? Good. It is a product rule, right? We have x cubed times sine y. So again, we'll let f be the x cubed. We'll let g be sine y. That means our f prime is just 3x squared. What's our g prime going to be this time? Good. Cosine y times the derivative of the inside, and because it's implicit, we have to have a y prime here. So now when we do our product rule, start with your x cubed, multiply that by g prime, which is cosine y times y prime. Then we're going to add sine of y times the 3x squared. So that's that first term. Now we've got cosine of 2y. What's our derivative for cosine 2y going to give us? All right, so derivative of cosine would give us what in general, right? So just what is the derivative of cosine? Negative, right? So just make sure it's a negative sine of 2y. And then we have to multiply by the derivative of the inside since it is a chain rule. What would be the derivative of the inside this time? Two y prime. Good. Right. So just make sure, right, it's not just a 2, right? If it was a 2x in there, right, the derivative would just be 2. But in this case, it's a 2y. And because it's implicit, we have to make sure we have a 2y prime as the derivative of the inside. Any questions about how I got that for the derivative of cosine 2y? All right, I'm going to erase this work over here just so we can find this next piece. So what are we going to have to use over here now for xy? What rule is that going to be? Product rule again. Good. I'll do that right up here. Let f be x. Let g be y. So f prime is 1, and g prime is what? Y prime. Good. Okay, so then product rule here would just give us x times y prime plus y times 1. So again, just before I actually start moving anything around, I'm just going to make sure that my terms look nice. So we'll have x cubed cosine y times y prime. Here I'm just going to move the 3x squared to the front. So 3x squared sine of y. Here I'm going to move the 2 to the front. So we'll get minus 2 sine 2y times y prime. And over here we just have x y prime plus y. So same thing. We want to get all the y primes on one side, get everything else on the other side. So here again, I've already got 2 y primes on the left. I'm just going to move everything that way then. Let me subtract my x, y prime from both sides. And that means I need to get rid of this 3x squared sine of y. I'll just subtract that on both sides. All right, so now we're left with x cubed cosine y, y prime, minus 2 sine 2y, y prime, minus x, y prime. And on the other side now, we just have y minus 3x squared sine of y. So then from there, what do we do? Good. Factor out the y prime. So that's x cubed cosine of y minus 2 sine of 2y minus x. And then at that point, we can just divide, move all that stuff in parentheses to the other side. So we get y prime is y minus 3x squared sine of y over x cubed cosine y minus 2 sine of 2y minus x. So again, just be careful, right, with your implicit. Anytime you're taking the derivative of a y term, just don't forget your y prime. Be careful with recognizing what rules you're going to use, right? So always look for those products. If it's a product rule, make sure that if you have any chain rules, right, functions within a function, just make sure that you actually use your chain rule to find the derivative of the inside there. Any questions on that one now? All right. So rather than starting the next one and maybe not getting all the way through it, let's stop there for today. Like I said, we've got all week to get through this, so I think we're good on time. But again, if you find something where you're like, oh, I really wish we could work through more of that type of problem, please let me know. and I'll be happy to look for more of those types of problems. Okay. So again, just a couple of reminders. Make sure that if you have not already signed up for an exam time next week, go ahead and use that survey link in the announcements to do that. Again, just as long as you do it by the end of the week, you'll be fine. Because again, I know a lot of people are waiting on work schedules and that kind of thing. Okay, but if you can go ahead and get that done, that'd be great. Double check your grades, right? Because now everything should be in there. So if anything seems to be missing or if something doesn't look right, please let me know so I can get that adjusted as soon as possible. Okay. I think that's all. So if you don't have any questions, have a great afternoon, and I will see you all tomorrow.